So we're going to talk about vertical and adjacent angles. And when you have two straight lines that cross each other, lots of different circumstances. You could even have maybe two parallel lines like this, and it's cut by what's called a transversal, or a line that cuts both of them like this. Then notice this situation looks like this, and this situation looks like this. So you could be given either situation, but the idea is this. Vertical angles are angles that touch each other on their point. So like this angle is vertical to this angle. And the opposite is also true. This angle is vertical to this angle. So that they're nose to nose in a sense, opposite each other. That's a vertical angle. And vertical angles are the same. So in this case, if this is 115, then this is 115. If this is 30, then this is 30. So when they start you off with something like this, and they only give you one measurement, you can actually figure out all of them. And the other situation is adjacent angles, which are the ones that are right next door, next to each other. Now, as long as they form these angles, as long as they together are next to each other and they form a straight line, notice how this one together with this one forms a straight line, or this straight line is formed by this 115 and then the A, those two together. Of course, B and C together form a straight line. This one and C form this other straight line. So as long as you can do that, we know that adjacent angles together, if you add them, they equal 180 degrees. So if we want to know how much A is, we just have to say, okay, we've used up 115 of those degrees here, because this whole thing has to equal 180. So we'll subtract the 115 and see how much is left over. And so because this one and this one together have to equal the 180, it's 115 plus 65. So in this case, angle A is 65 degrees. And angle B has to be the same as the one across from it, so that's 115 degrees. And angle C is vertical angle to angle A. They have to be the same. So if A is 65, then C is 65 as well. And down here in the transversal, if we had that same situation, if we said, oh, this is 115 here, and that makes this 115, and we figured out that this was 65, and this was 65, then interestingly, the next intersection has to be exactly the same. If this was 115 here in this upper left-hand corner of the intersection, then this one also has to be 115. They're corresponding angles. And then, of course, that makes all the rest of this the same as well, because this bottom left is the same as this bottom left, and so forth. So we could find all of those angles just by knowing one set.